Hi everybody, this is Dr. Nageshwar Rao, Assistant Professor of Physics, SRR and CVR Government Degree College, Autonomous Vijayawada. Today we will discuss about De Morgan laws. These laws are very much important for Boolean algebra calculations. Actually, De Morgan laws are two statements we have. There is a De Morgan first law and a De Morgan second law. De Morgan first law states that the complement of the sum of the two or more variables. For example, if A and B are two variables, then the complement of the, complement is nothing but inverter. There is A plus B bar because the complement is bar is there. Sum is nothing but plus is there. Two variables here. So A plus B bar shows that the complement of the sum of the two variables. This is equal to where A bar is nothing but complement of A bar A and B bar is complement of B and there is dot product, that is product. So that this is equal to product of the complement of the two variables. This is called De Morgan first theorem. So De Morgan first theorem states that the complement of the sum of the two or more variables is equal to product of the complement of the such variables. And in the second form of this De Morgan first law states that there is a plus is nothing but OR gate and dot is this is product is nothing but AND gate in logic gates. By using this OR gate and AND gate we can define this De Morgan first theorem. So by using OR gate and AND gate we can state that when two or more inputs or two or more variables add with and negated, add is nothing but OR gate, there is a plus, negated that is nothing but NOT gate, that is inverter. That is equal to AND of the where dot product is there, that is dot is nothing but AND gate, AND of the complements, that is nothing but NOT gates are there of the individual variables. So this is also called De Morgan first theorem. So De Morgan first theorem states that when two or more variables are and negated, and this is equal to ANDed of the complements of the individual variables. So mathematically, we can show that A plus B bar is equal to A bar into B bar. This is called De Morgan first law. So there is A plus B bar. So how can we show? By using logical diagram. So A plus B is nothing but OR gate. We know that is this is the symbol of the OR gate. There is the inverter is nothing but NOT gate. This is the NOT gate. So by adding this OR gate with the NOT gate is shows that A plus B bar. So there is OR gate is nothing but output is A plus B. There is NOT gate is nothing but A plus B bar. And the second one is A bar into B bar. A bar is nothing but you see here output input A is there. This output of the first NOT gate is A bar and B is input or variable. The output of this second NOT gate is B bar. So there is into, there is nothing but AND gate is required. So another AND gate we are using here. So A bar and B bar are now inputs of the AND gate. The output is A bar into B bar. These two are equal because according to the De Morgan first theorem, A plus B bar is equal to A bar into B bar. So that this is three equals are there. So those are exactly equal. So this is the logical diagram of the De Morgan first theorem. So that finally we may say that A plus B bar is equal to A bar into B bar. How can we verify this one? So let us consider two variables, that is A and B are there. There is two variables is nothing but four combinations, that is a 0, 0, 0, 1, 1, 0 and 1, 1 we have. Because two variables is nothing but 2 square, that is four combinations we have. There is outputs of these De Morgan first theorem is first one is A plus B bar and second one is A bar into B bar. So that where we have to take A plus B. So 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1 and 1 plus 1 is 1 we know according to the OR gate. Now the complement of this A plus B bar, complement of 0 is 1 and complement of 1 is 0, complement of 1 is 0, complement of 1 is 0 because we know complement is nothing but inverter gate. That is not gate. Not we know output. If the input is 0, output is 1. If the input is 1, output is 0. That is the output of the NOT gate. And the second part is we know A bar into B bar. So what is A bar? A bar is nothing but complement of the input A. So 0 input is 1, output is 1, and 0 inverter is here 1 inverter is 0, and 0 inverter is 1, and 1 inverter is 0. Similarly, there is B bar. So 0 inverter is 1, and 0 inverter is 1, and 1 inverter is 0, and 1 inverter is 0. Now what we required? A bar into B bar. That is A 1 into 1 is 1, we know. 0 1 into 0 into 1 is 0, 1 into 0 is 0, 0 into 0 is 0. So when we observe this truth table, there is output of A plus B bar is 1 0 0 0, and A bar into B bar is also 1 0 0 0. Both are identically equal. So that A plus B bar is equal to A bar into B bar. This is verification of the De Morgan first law. So individually we can write one by one like this. For example, if A is equal to 0 and B is equal to 0, A plus B bar is equal to, that is 0 plus 0 is 0, 0 inverter is 1. And A bar inverter into B inverter into B inverter, that is 0 inverter is 1 and 1 0 inverter is 1, 1 into 1 is 1. So both are inputs, outputs are 1 and 1 equal, so that A plus B bar is equal to A bar into B bar. And the second combination, if A is equal to 0 and B is equal to 1, then we know A plus B is equal to 0 plus 1 is 1, 1 inverter is 0. And A inverter into B inverter, A inverter is nothing but 0 inverter is 1, and B inverter is nothing but 1 inverter is 0. 1 into 0, 0. So both outputs are 0, so that A plus B bar is equal to A bar into B bar. And third combination in the above truth table, if A is equal to 1 and B is equal to 0, that is A plus B bar is equal to A 1 inverter, 1 plus 0 inverter, that is 1 inverter, that is 0. And A inverter into B inverter, that is 1 inverter is 0, B inverter is 1, and that is 0 inverter is 1, 0 into 1 is 0. So both outputs are 0 and 0, so that A plus B bar is equal to A bar into B bar. Similarly, if A is equal to B and 1 and B is equal to 1, then also A plus B bar is equal to 0, and A inverter into B inverter into 0. That is A plus B bar is equal to A bar into B bar. So from this analysis, what we said that De Morgan first theorem is verified. That is A plus B bar is equal to A bar into B bar. So thank you very much. And the second one is De Morgan second theorem states that is exactly opposite to the above theorem. That is, if two or more variables, then whose product of the complement? You said A and B are two variables whose product of the complement, that is equal to complement of the variables whose sum. So sum of the complements of the such variables. This is called De Morgan's second theorem. We know first theorem is that A plus B bar is equal to A bar inverter into B inverter. Here is AB bar is equal to A bar plus B bar. So what we have said, the complement of the product of the two or more variables, that is equal to sum of the, because the plus is nothing but sum, we know, sum of the complement of the such variables. This is the De Morgan's second theorem. And of course, by using AND gate and OR gate also, we can define this as De Morgan's second theorem, because we know this product is nothing but AND gate. This is a plus is nothing but this OR gate, we know. So from that is the two inputs variables are ANDed. It's nothing but by adding AND gate. And a negated, that is nothing but NOT gate, because the inverter is there. That is equal to R of the, because R gate is nothing but sum of the complements of the individual variables. So that De Morgan second theorem states that the two or more variables are ANDed and negated, that is equal to sum of the complement of the two variables. This is called De Morgan second theorem. So there is outputs are A B inverter and A bar plus B bar. So A B inverter in which A into B, that is nothing but AND gate we require. There is a bar is there, is nothing but NOT gate is required. So that AB bar. So that we know AB is nothing but that is output of the AND gate is AB and output of the NOT gate is bar. So that AB bar. And the second part is we know A bar plus B bar. A bar is nothing but there is one NOT gate. Here NOT gate is there. The first input is A, whose output is A bar. And the second input is B, output of the NOT gate is B bar. But there is plus is nothing but we required OR gate. So that OR gate is used here. There is A bar plus B bar. These two are equal according to the De Morgan second theorem. So this is taken as identically equal. So that A into B bar is equal to A bar plus B bar. So by using truth table, we verified this A B bar is equal to A bar plus B bar. Because there is also two variables we have. One is A and second one B. There is two variables is nothing but four combinations we have. That is a 0, 0, 0, 1, 1, 0, and 1, 1. By same analogy, we know AB bar is equal to 0 into 0, 0, 0 inverter is 1. 0 into 1 is 0, 0 inverter is 1. 1 into 0 is 0, 0 inverter is 1. And 1 into 1 is 1, 1 inverter is 0. Similarly, here also there is A bar plus B bar, 1 plus 1 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 0 is 0. So both outputs are equal 1, 1, 1, 0 and 1, 1, 1, 0. So that the Morgan theorem, so mathematically we can write that AB bar is equal to A bar plus B bar. So we can verify by using different inputs or different variables. For example, if A is equal to 0 and B is equal to 0, AB bar is equal to 0 into 0, 0 bar, that is 1. Similarly, A bar plus B bar is equal to 1. So both outputs are equal. And if A is equal to 0 and B is equal to 1, that is AB bar is equal to 1 and A bar plus B bar is equal to 1. Both outputs are 0. That is AB bar is equal to A bar plus B bar. And third combination, if A is equal to 1 and B is equal to 0, A, B bar, that is 1 into 0, 0, 0 bar is 1. And A bar, 1 bar is 0 and 0 bar is 1, 0 plus 1 is 1. Both outputs are 1s. And last combination is if A is equal to 1 and B is equal to 1, then A plus B bar is 0 and A bar plus B bar is also 0. So that A bar is equal to A bar plus B bar. From these four examples, we can say that De Morgan theorem is verified and hence A B bar is equal to A bar plus B bar. So thank you very much.